Where should we start? Where should we start? Use hands. We're using hands. We're using hands. Right there. 18. Is that a good place to start? You're seconded. It says, find the principal interest needed now. Principal needed now to get the each amount. That is, find the present value. To get $800 after 2.5 years at 8% compounded continuously. So what formula is for continuous interest? Pang? What formula is continuous interest?
P, E,
To the...
R.
Yeah. P, pert. Like that. Only E is being raised to the RT power. Only E. So what amount do we want to have? So that corresponds to which? To A. So 800 is equal to, we don't know P. What's the interest rate? So what's that in decimal? And what's the time? 2.5. So what does P equal? 800 divided by e to the 0.08 times. Now that's something you can do on your calculator. So how about we do e first? So second, e to the 0.08 times what? 2.5. We hit enter, and then we do 800 divided by that. We end up with $654. So if you wanted $800 at the end of that time at that interest rate, how much money would you need to put into the account? $655. Does that make sense? These questions are testing your ability to substitute and solve. They just want to make sure you're familiar with the formulas. Using a hand, which one next? Shock?
21.
21? Okay, so I get to do the same thing I did with the last block, which is prove something about teenagers, which you already know and is consistently, I guess, not surprising. So why are you asking about 21? Yeah, go finish it. Go ahead. You didn't look up what? Okay, I just have a quick question. How many of you were on the internet for at least 5 minutes last night? How many of you were on the internet for at least 5 minutes last night? Okay. Ready, everybody? Dude. Effective interest. First oh, look at that. Look at all this information. Are there millions of entries? Not just Wikipedia, but all over the place? Look it up. Do it, please. When you run into a wall and it's a specific term like effective interest rate, can you find it pretty quickly? To summarize what effective interest rate is, how many different ways can you compound an account? Monthly, daily, continuously, quarterly, biannually, semi-annually, every trimester, right? The more you compound, the more interest you make, correct? So if you have tons of different interest rates and tons of different compoundings, let's say you were a consumer and you were choosing which one to take, what would you need in order to compare them? You need to have some sort of common metric. You'd have to have some common way to compare them. What's the way we're going to compare loans? With the effective interest rate. The question essentially states, if you have such and such a situation, the effective interest rate is what is the interest rate if you were just going to take the interest once. So for example, 5.25%, we're compounding it what on this one? Quarterly. We're compounding it quarterly. So let's just give a specific situation. How much money do we want in our account? Let's say $100. That's a good number to start with. And we're going to go for 1 year. 1 plus 0.05 what? 25 over quarterly, so 4. For 1 year, what are we going to raise it to? 1 times 4. So if you do that, can someone do that on the calculator for me? You should end up with, I think, $105.35. Can someone verify that for me, please? Score. Okay, so here's the deal. What did we start with? We started with how much money? And we ended up with? What was our percent growth overall? We went from 100 to 105.35. We had a 5.35% increase, right? This is everybody, that's the effective rate of interest. So for example, let's say I had 5.1% continuously for a year. This is lower than 5 1/4? Yes, but we are compounding more often. So can you just say off the top of your head, is that better or worse? No. Are you able to do the equation in your head? No. What could you do? 100 times e to the 0.051. How many years? 1 year. Someone do that on their calculator. Tell me what you get. 100 times e to the 0.051. What do you end up with? Look at this, everybody. So if you did continuous interest at a lower interest rate, what do you end up with? What's the effective interest rate? 5.23 increase. That is also the effective interest rate. So if you had to compare these and you were trying to make money, which one would you choose? 5 1/4 quarterly as opposed to 5.1 continuously. So what is the overall main purpose of determining an effective interest rate? Comparing what?
Like 2 different interest rates?
Different situations. Because it has to do with the rate and how often you're compounding. Effective interest rate is what is the simple annual interest rate. In this case, the simple annual interest rate is 5.35 as opposed to 5.23. Now, overall, are those numbers wickedly different?
No.
They're not wickedly different in terms of just looking at the numbers, right? But if you were applying that to a loan over 30 years, could that make a big difference? Yeah, it could make thousands of dollars of difference. Go to lunch. Okay, number 30. How long does it take for an investment to double in value if it is invested at 10% per annum? What does per annum mean?
Year.
Monthly. Okay, so if we're compounding, so what is our A equals what? What's our formula? P times 1 plus R to the T. That's it. That's per year, right? We don't have to divide by, because what is N in this case? If it's per year, what's N?
1.
1. So we're just not going to write it. So what are we doing? What are we doing? We're doubling it. The amount we end up with is A or P. Which one is it? So if we want to double the amount we start, to P. What's the amount we start with? P. So if we want to double the amount we start with, it becomes what? So what can we cancel? 2 equals 1 plus R to the T. What's the interest rate? 2 equals 1.1 to the T. Right? So what do we have to solve for? What kind of equation is that? No, what type of equation is that? Exponential. In order to solve for T, what do we need to use? Log base of equals. So if you need to punch that in your calculator, T is equal to log of 2 over log of 1.1. Can someone do that and tell me what it is? What did you get? Do you agree with that answer? I didn't use log, did I? What did I use? Does it matter? No. As long as they have the same base, top or bottom. Same thing. So how long does it take? A little over?
7 years.
So like 7 years and maybe a few months? Something like that, right? Okay, now it says, how long does it take to double, but not, it says compounded continuously. What's the continuous interest formula, or continuous A equals what? Pert. So again, what's the amount you're going to end up with? So it turns into 2 is equal to e to the, what's the R? 0.1 t. Right? Log base what? Ooh. Let's do log base what? If we translate this to log form, what is it? Log base e to the 2 equals t. So what does t equal? 10 ln 2. So does it take more time or less time? More time or less time to double? Why does it take less? Because you're compounding more often. You are now continuously, which is compared to before, You're now compounding more often. The more you compound, the faster things grow, right? Remember, that's a universal constant we're talking about. And then it asks, does it ask for one more, I think? It asks for, verify using a graphing utility. How could you verify this using a graphing utility? How would you use a graphing utility to verify this? What would you graph? So it turns into ln of 2.5, enter, divided by 0.06, and you end up with 15. A great way to understand if to check reality is to say out loud what your answer means. So what does that answer mean in terms of this question? To turn $10,000 into continuously at 6%. Yeah. Double times. Yep, absolutely. Okay, so we're going to change gears here. And just as a demo, we're going to talk about 47, but we're not going to write down anything for 47. We're going to talk about it out loud first. Here's 47. Jess, can you read it out loud for me, 47?
Colleen and Bill.
Did we start with? That was a nice amount to start with. $100, right? And we multiplied by 1 plus, this would be simple interest right here, per annum. This turned $100 into 100 plus a little bit more, right? Well, our effective interest was what the percentage growth rate was. The percentage growth rate was actually this. The percentage growth rate is actually what you multiply 100 by minus 1. Because what is 1 in percentage form? 100%. 1 is 100%, right? So if you grow something, it turns into 105% of something, right? It's what it was plus 5%. So if you want to grow something by 105, if you want to grow something by 5%, what do you multiply it by? 1.05. What do you say the growth rate is if something goes from 100 to 105? The growth rate was 5%. So to get from 100 to 105, you multiply by 1.05, but we say that the growth rate is 5%. So we need to subtract 1 from this. Does the initial value matter at all when calculating effective interest rate? No. So what's the formula? So if we want to do A right here, it's going to be 1 plus 0.12 to what power? It's per annum, right? 1 year. What's 1 plus 0.12 minus 1? 0.12. The definition of simple interest is what is the yearly interest rate. So what is the first question telling you? The effective interest rate on the first one is the interest rate because it is per year. What about the second one, though? What about the second one? What's happening here? On the second one, is the interest rate is lower, but you're compounding it more. In this case, it's still 0.12, but you're compounding it what? Every what? Month? So you divide by? Thank you. Very important. Yes, that's the whole problem, right? Divided by? Raised to the what power?
No.
It's per... No. This is not continuous. It's monthly. How many times per year?
12.
Yeah, times 1, because it's 1 year we're talking about. So if you do this out on your calculator, if you do out, 0.115 divided by 12, 1 plus second answer, and you raise that to the 12th power, you end up with that, and what do you have to subtract? 1. So what do you end up with? You end up with, what's the interest rate? Exactly, it's a little higher. So the interest rate you end up with is so you end up with a 12.126% effective interest. So if you took the interest rate once at 12.126, it would be the same as doing 11.5 compounded monthly. So right now, if you just had to choose between the two, which one's better? No, you want to.
No,
you
we want the least.
You want your. This is what you're paying, so you want to pay less money. So which one's better for you right now? The first one. Let's check out the third one. Now we're only going down by 0.25%, but we're compounding it continuously. So maybe it bumps it up too high. Let's check. So again, what equation are we using this time? Yeah, the p doesn't matter. So it's e to the t subtracting what? 1. So in this case, it's going to be e to the 0.1125 minus 1. If you do that out, second e to the 0.1125, and you subtract 1, what do you end up with? Ah, This is the best effective interest rate for you because, why? Yeah, it's the smallest value, exactly. So in this case, you end up with an 11.907% effective rate. So what's the lowest rate for you? 11 and a quarter. So you see how hard it is to, if you just look at the percentages, to figure out which one's the best value? Yeah, and there's other things that go into this. If you look at housing loans, for example, sometimes there's fees. Like on credit cards, you might pay a specific interest rate in addition to like a monthly fee. So when you're looking at loans, sometimes there are monthly fees, sometimes there aren't. Sometimes there are fees for setting it up, origination fees. Sometimes they're bigger, sometimes they're smaller. But the banks have to report the equivalent of an effective interest rate. Why do they have to report an effective interest rate? To make it so that, or just regular consumers who aren't PhD math and banking students can understand the deal they're actually getting, right? I mean, how easy it would be to bury fees? Oh, it happens all the time, right? I mean, do you really truly understand your cell phone bill? I mean, and most of you don't even see it, but have you ever looked at a cell phone bill? It's terribly complicated, right? I mean, theoretically, you understand what's going on. You have like the bullet points, you can drill down through it, but is it really easy to get lost in like how much something costs? Is it really easy to hide how much something costs? Yeah, especially the bigger the value, right? So with the biggest things you're probably going to purchase in your life, maybe a house, it's kind of good to understand what these things are. Okay. Really common length of time for loan payment is 1 month. Oops. Is 1 month. So what do you want to figure out? What is the interest rate so that when you're done here, you end up with, it goes down to $0. You have to figure out how much you have to pay, because this gap, what does that represent? How much you pay each month. Does this make a little bit more sense now? Does this kind of make a lot of sense? A little bit? Maybe? So I mean, what I mean by that is if I owed you $12,000, I might actually be paying you less than $12,000 every month. I might be paying you a little bit more. It depends. Let's just take a look at this for a second. Why is it going up? Why is my debt going up? It's taking time. Interest is accruing on my debt. But then when I make a payment, what does it do? It goes down, but then it goes up, down, up, down, up, down, up, down, right? You're aiming to have zero debt in that loan at the end of a certain amount of time. What's the average car length of loan? Like 3 to 5 years is pretty average for a car loan. 3 to 5 years. So you need to calculate this little step here. I cannot prove this formula in this class, but I'm going to give you the formula which we're going to use. A equals P times I, and I'll explain what all of these mean, 1 plus I to the n over 1 plus I to the n minus 1, where A, you already know some of these, and they correlate, some of them. A represents monthly, we're going to call it monthly payment amount. P represents your principal. If it's a loan, this is just the original loan amount. N, this is a little different, equals number of payments. And this is a huge difference. I, in this case, is going to be the periodic interest rate. Whoever's clicking plastic back there needs to stop. What I mean by that, we call it R divided by the period. What I mean by that is we've been looking at yearly interest rate. What do we divide the yearly interest rate by if we want to have the monthly interest rate? Divide by 12. Yeah. So what practical situations can this be used in? Let's just do one. How much is our car going to cost? $10,000? What's the interest rate going to be per year? What's the interest rate going to be? 5%? How long is the loan going to be for? 3 years. So I could ask you the question, how much do you need to pay per month to satisfy this loan? Well, The amount we're going to pay per month is going to be the principal. What's our initial principal? This is the debt, the initial debt. What is I going? This is the trickiest part. What is I going to be here? What's the periodic interest rate? Well, we're paying off monthly, so we're going to divide the yearly interest rate by what? 12. What is the yearly interest rate as we stated? We called it 5% for our yearly interest rate. So it's going to be 1 plus 0.05 divided by 12 raised to what power? N is the number of, what did you say? Why did you say 36? How many months in 3 years? 3 times 12. Exactly. Over 1 plus 0.05 divided by 12 to the what power? 36 minus what? 1. This gives you your monthly payment in order to pay this loan off. This is a useful formula. Now, if you're going to compute this, actually come up with a number, what are you going to have to use to do this? What? You're really going to have to use your calculator, right? Now, let's just talk about the proper way to type this in. Can someone tell me one way you should not try to type this in? All at once. Please, please don't do that. If you miss one parenthesis, what happens? It's just, you're totally done. You'll get some really weird answer like your monthly payment is $6 million. It will not work. The easiest way that I like to type this in, look, you have the same thing in the top and you have the same thing in the bottom. So actually on your calculator do 1 plus 0.05 divided by 12. And what power do we raise that to? I wanted to, sorry, 1 plus 0.05 divided by 12. And we're raising that to the what power?
36.
The 36 power. So we did 1 plus 0.05 divided by 12 raised to 36 power, and we're going to store that as A. So anytime I write A, what do I have? That number. So now what are we going to do? 10,000 times, now go back to the formula here. We're actually missing something on top. There's something on the top of the formula we're missing. You see that I missed that before. If you don't multiply that I, your number is going to be way too big. What was I again? So what are we missing up here? Yeah, we did that same exact thing in the last class, and our answer was like $26,000. We're like, probably not the monthly payment. So you just now need to multiply out 10,000 times A times 0.05 over 12 divided by, is that a little easier to type into your calculator? As in a lot easier? Yeah. So you have 10,000 times A times 0.05 divided by 12 divided by A minus what? 1. Look at that. What does that tell us? So if you wanted to buy a $10,000 car and pay it off in 3 years, what's your monthly payment going to be if the interest rate was 5%? About $300. Is that a realistic type of answer? Yes. Now let's think about this. So how many payments do you make? What does that tell you?
Means they earn $800 pretty much in interest.
They earned how much? $789 in interest. $789 in interest. Yeah, so we need to do 1 plus 0.05 divided by 12 raised to the 60th. And this time I'm going to save this as alpha A. So now we have 10,000 times 0.05 divided by 12 times what? Alpha B? Was it? No, I saved it as A, didn't I? Sorry. No, you don't need it because multiplying and then dividing, you don't have to have it. So we multiply that times A. And now what do we divide by? A take away 1. What do we end up with? $188. So does that make sense? Should our payment be lower? Yeah, a longer time. It's the same amount of money, but it's a longer time. So we ended up paying now $188.71 per month, right? But how many payments do we make?
Oh, they make a lot more.
Yeah. So in terms of over time, though, what does this mean? It means that so that's your monthly payment, but Let's answer the question. So that would be your 5 years, your monthly payment. Overall pay, that's how much you pay overall. But how much interest is that? $1,322.74 in interest. But back here, what was your interest payment? 0.52 interest. Does that make sense, everybody?
That's how banks make money.
Sure, but they're paying. You're paying so that you can buy something very, very expensive that you do not have the money for right now. You're paying it over time, and the cost of doing that is money. The cost of borrowing money is money.